All right. I think I'm ready to give you one more of these, and then I'm ready to start getting into the hard stuff, which is how we're going to factor these. So I'm going to bring up the problems that I started with here. So I want us to do these two right here. So for these for those two, same instructions. What are the zeros? What are the multiplicities? Do you cross or do you bounce? And then what's the end behavior? So look at that first one. K2 of x equals 2x minus 5. Okay, x plus 1, x plus 3, x minus 4. All right, let's list the zeros. Let's do the easy ones first, right? The easy ones are this one, and this one. So what are these zeros? -1, -3, +4, -1, -3, +4. Okay, what about that one? How do you do this? Because these you've just been taking the opposite, right? But what you're actually doing is setting these equal to 0, right? Yes? 5/2. So all you're doing is taking 2x minus 5 and figuring out where it's 0, right? And so you just solve this equation, move the 5 over, divide by 2, you get 5 halves. That's actually what we've done for each of these. Set that to 0, that to 0, that to 0. You get the opposite answers. But here, because of the 2 in front, we actually get a fraction. So I'm going to put 5/2. All right. What about multiplicity? Yes? You could write that as 2.5, yes. They all have the same multiplicity, don't they? They all have the same multiplicity. They're all what, 1s? So they all cross, right? All of these multiplicity is 1, which means we cross at all of them. Last thing, end behavior, right? End behavior. And to do end behavior, make sure you're doing what I showed you here. You take everything here, right, to the first power. So 2x to the first power times, this is just x, right, to the first power, times this is x to the first power, and this is x to the first power. And all that together gives you 2x to the fourth power, right? So even power, or even degree, positive leading coefficient, so that means both sides should go up. Okay. We good? All right, I'm ready to look at everything we've done up to this point is just so you understand how the zeros and multiplicities and all that is connected. But now we are going to look at like the real issue here, the type of thing you're going to see on a test, right? On a test, you're going to see something like this. So I'm going to take that G1 function here, and x to the 5th minus 13x to the 4th plus 55x cubed, okay, minus 75x squared. All right, so what I want us to do is I want us to basically sketch this. So to sketch it, you're going to need to know the end behavior, and you're going to need to know the x-intercepts, and you're going to need to know the multiplicity of those x-intercepts, right? So let's first step on this, let's find the end behavior. The end behavior, what's the degree? It's odd, right? 5, it's odd. And the leading coefficient is 1, right? It's the one in front here. And so that's positive. And then using that table, you know that the left side should go down, the right side should go up, and in the middle is a big question mark. Okay, so we've got that established to start. Now, we need to find the x-intercepts and the multiplicities. The x-intercepts and the multiplicities. How do we find x-intercepts of a function? We take the function and we set it equal to 0. So I'm going to take, yes, this big nasty thing, x to the 5th minus 13x to the 4th plus 55 x to the 3rd minus 75x squared, and we're going to set it equal to 0. And we're going to go shit, right? Okay, maybe this will work, maybe not, I don't know. Okay, so first step for factoring is GCF. Do y'all see a GCF? Each one of these terms has an x squared, right? So I can pull an x squared out. Let's do that. That leaves me with x cubed minus 13x squared plus 55x minus 75 equals 0. Now, right now, you can tell me one of the x-intercepts. 0, right? There's one of your, I should put equals here. Oh, no, because we're solving, right? I already know that I have an x-intercept of 0, don't I? And I know that at that 0, what do? What's the multiplicity? It bounces. So I know when I draw this graph, I'm going to bounce off 0. I know that so far, but all this shit in here, I have no idea, right? I need to see if I can factor that. So how do you factor this? So grouping is what you normally use if you have 4 terms, right? How many of you grouping, yes or no? And half of you? Okay, so grouping is what we normally use if you have 4 terms, but grouping is going to fail. It's not going to work. You can try it, it's not going to work. If you don't believe me, you can try it, but it's not going to happen, all right? So hopefully when you learned grouping, they told you like, hey, grouping sometimes works, it sometimes doesn't. Doesn't always work for 4 terms. But it does factor. It does factor, but not with grouping. We have to introduce a new type of factoring, all right, that most of you have probably not seen. Maybe you have. But it's going to require we develop this concept of, well, it's a technique, something called synthetic division. So how many of you have done synthetic division? Yes? Okay, we're going to use it. We're going to use this technique of synthetic division to actually factor something, all right? So right now, I'm going to say stop, okay? That's an S. Sorry, we're going to stop, okay? And we're going to come back to this problem after we go and take some time to develop the technique with this synthetic division and how we can use it to factor, okay? So can everyone put this on the back burner for right now? We will revisit. I don't even know if we'll get to it today. Let me see. We'll see. I don't think so. So I think what I'd like to do is do it this way. We're going to say a new way to factor. And it may not be new to you, okay? If you've seen it, then it's not going to be new. But for most of you, it'll be new. All right, so let's take a look at something we already know how to factor, all right? Let's take a quadratic. Let's take something like, let's go with this. Let's just first verify that that does factor, all right? So the way that we've learned before is either guess and check, right? Where you just come up and you try and come up with this yourself, or you come over here and you say, okay, I need 2 numbers that multiply to be -8 and add up to be -2, and then you do that thing that I showed you, right? Is -4 and +2 work, right? So this should factor to be x minus 4 times x plus 2. We all agree with that? You FOIL that out, you get the correct answer. Now I'm going to show you another way to do the same thing, okay, but using what's called synthetic division. Now when you see this method, especially when you see it on this problem, you're going to be like, why? Why do that when you can just do this? And I would agree with you. But the problem we just stopped on, we have no way of factoring it. And so this is the way we're going to do it, okay? So right now, again, it's not going to make a whole lot of sense why I'd want to do this in this scenario, but we're going to do it. So how does synthetic division work? Well, the first thing you do is you draw a division box, but not like this. You know how we normally write division boxes like this? We're going to do it reverse. It's upside down. It's like this. And then what we're going to do is in this division box, we are going to put just the coefficients of this polynomial. And you have to make sure that your polynomial is in descending order, highest power down. So 1, -2, and -8. I'm going to put those numbers in this division box. 1, -2, and -8. And notice I left a space underneath these. That's intentional. Make sure you leave a space there. Okay? And then what we're going to do is we're going to start doing this thing called synthetic division, where we put a number out here and we start doing something with it. All right? But you've got to know what number to put out here. And so the question becomes, where do you get this number from? All right? So the next thing you do is you come over here, and this is going to be really the tedious part of this. You're going to look at the number in the back of the polynomial, right here. And don't even worry that it's negative, okay? Don't even worry that it's negative. I want you to make a list of all factors of 8. All the different numbers that you can multiply together to get 8. So how about 1 and 8? Yes? 1 and 8? How about -1 and -8? Yes? So I could have a +1 or -1 along with a positive or -8. I put them on the ends because what I'm going to do is start working my way in to make my list. So do you all agree 1 and 8 multiply to be 8 and -1 and -8 multiply to be 8? What other numbers? 2 and 4, right? Or -2 and -4, right? So ±2, ±4. Anything else? 3 doesn't, right? 3 is not a factor of 8. 4, is 4 a factor of 8? Yes, but we already have 4, right? So we're done. As soon as we get to a number that's already in our list, we can stop. Those are all the factors of 8. Now what we do is we look at the number in the front, and we list all the factors of 1. All factors of 1. And what are the only numbers that multiply to be 1? 1 and 1 or -1 and -1. So all you have to say is ±1. Okay? The last step to get this list, to get what number we're going to put here, the last thing you have to do is make a final list. And the final list is every number here divided by every number in this list. Now, fortunately for us, there's only these numbers in this list, right? Just these. So I would take this, divide by that, this divide by that, this divide by that, this divide by that. But do you all see that when I do that, I just get this original list up here? Because that's just a 1, our final list is actually going to be identical to this list. However, if this had been, I don't know, a 3, right? Then our factors would have been ±1 and ±3, and then we would have had to have done, you know, this over 1, this over 1, this over 1, this over 1, but then also this over 3, this over 3, this over 3. We have a bunch of fractions. It would suck. That's coming. Not yet. This is the first example. So ±1, ±2, ±4, ±8. Okay. This is our final list. Any questions? Trust me, when you do synthetic division enough, this starts to become extremely fast. You start to get quick with it. All right, what I'm going to do now is I have, how many numbers are in this list total? There's 8 numbers, right? Positive and -1, positive and -2, positive and -4, positive and -8. I have 8 numbers that I'm going to use to try and see if I can get something over here to happen. All right? So let me show you what you do. Let's start with the first number on that list. I'm going to start with +1. Put a +1 out here. Yeah, let's put +1 out here on the outside of the box. Okay, some of you said you know that you've seen this before. Does anyone want to help me explain what you do now? Like how you actually go through the synthetic division process? What's the first step? Once I put that number out here, and I've got these numbers in here, what's the first step? Remember? No? Go ahead. What? Don't remember? Where? Right here? Yeah. Okay, you could, yes, you could look at that as a step. Put a 0 here. Okay, that's fine. I'm okay with that as a first step. And then what? You add down. You just add down. I'm going to put an A for add. You add down. What's 1 plus 0? 1 plus 0. 1. Put that here. Okay? That's your first step. You're just going to take this number. That will always be a 0. Add down, you get 1. Now, the next step, what do? Take this 1, multiply that together. What's 1 times 1? 1. You put that answer underneath that right there. Okay? Then you add down again. What's negative 2 plus 1? Negative 1. Okay? Now, multiply again, right? Multiply here. What do you get? 1 times negative 1 is? Negative 1. You put that answer here. And you add down again, last time. Add down. What do you get? Negative 8 plus negative 1? Negative 9. Okay, that last number we put in a little box like this. What we need in order for synthetic division to work and actually factor something for us, we need this number in this box to be a 0. If it's not a 0, then the number just failed and we need to move to the next number in our list. Okay? So it just failed. I realize this is tedious, but there's no other way to factor when you get to bigger things like the one we stopped at. This is the way, all right? Okay, so this failed. Why this fail? This is not 0. Okay, so what number should I try now? Let's see, same numbers in here. 1, negative 2, negative 8. I just tried 1, didn't I? Let me try negative 1. Okay, let me try negative 1. Put a negative 1 here. Sure, put a 0 here. Add down. Add down, what do you get? 1. Okay. This times this, negative 1, put it here. Add down, negative 3, multiply here times here, positive 3, add down, negative 5, failed. Okay? How many times do you have to do this? Until you get 0, okay? I'll leave that there. Let me do another one here. What's the next number we should do? 2. 1, negative 2, and negative 8, right? I'm putting 2 on the outside, right? Okay, put a 0 here, add down, we get 1. 2 times 1. 2, oh, add down. Add down. 0. 2 times 0. 0, add down. Negative 8, shit. Failed. Okay? 0 here is not what we're looking for. 0 here is what we're looking for. All right, the next one's going to work. I'm going to use negative 2 now. 1, negative 2, negative 8. And I'm going to use negative 2 out here. Okay, since this one works, let's take our time. Put a 0 here, add down. 1. Negative 2 times 1. Negative 2. Negative 2 plus negative 2. Negative 4. Negative 2 times negative 4. 8. Ah, there it is. Negative 8 plus 8. 0. Okay, that's what we want. Now, how does that give us this answer though, right? How does that give us this answer? Well, actually, this answer is there. It's hidden in here. You just have to kind of squint your eyes and you'll see it. Okay, first thing, if you take that number, I'm telling you that that is a 0. It's telling you that that is a 0 of the polynomial. If that's a 0, then what's the factor? X plus 2, right? X plus 2. So it's always the opposite of this number, right? If this is negative 2, you're going to put x plus 2. Like if this had worked, we'd put x plus 1. If this had worked, we'd put x minus 2. So that's the first. Do y'all see where the other part comes from? Right? The other part of the answer is supposed to be x minus 4, right? Do y'all see it? These are the coefficients of your answer, right? What's the number in front of this x? 1, and then minus 4. So this part right here, this here, tells you that what you have left is x minus 4. You have to understand that this is the number in front of x, and this is the number that's by itself. And that's factored now.
So would there be one more since there's x plus 2?
Well, we're factored, though. We're factored. We could continue. We could do synthetic division and keep going, because there would be another answer, right? What else would have worked in synthetic division? Can we tell by this? What else would have worked on the outside of this? Positive 4 would have worked. Positive 4, because x minus 4 is a factor. Yes? You have a big list? You'll have, yeah? Yeah, we have to go into this a little deeper now. This is just to get like the base idea of what we're going to be, like how it works, okay? Next class, we're going to get into like how do you do this, right? Like how do you do it when you have got like 7 things, right? Okay, any questions? All right, let's, do y'all want to try the other one that we stopped at, or do you want another example? What do you want? You want a higher one? Let's do something higher. Let me see. I need it to work, so hold on. Okay, here's one. Here's one that you cannot do by grouping. Okay, x cubed plus 12x squared plus 45x plus 54. The instructions here are to factor, okay? Factor this. I'll leave this right here. The instructions here are to factor. So, do you have a GCF? Do you have a greatest common factor? You always want to see if you can pull a GCF. Yeah or nay? No, right? There's nothing you can pull out of all of those. Okay? How many terms do you see? 4. Okay, you can try grouping. It's not going to work. I don't think it works. No, it doesn't work. Okay, grouping's going to fail. But you know what? You actually don't even need grouping anymore because you have the synthetic division. Okay? It's more powerful than grouping is. And if this did factor by grouping, synthetic division would also still work for us. So, all right. Start with what? First list is all the factors of what? 54. Shit. Right? All the factors of 54. Okay, positive and negative 1 and positive and negative 54, right? 1 and 54. I hope I left enough space in here. I don't know if I did. What else? 2 and 27. Positive, negative 2. I'm going to put more space just in case. Positive, negative 27. Positive, negative 54. The reason I do it like this is so that when I do have my list, at the end my list is going to be in order. Okay? It's going to be smallest to largest. Okay, does 3 go in there or no? 18 plus or minus 3 plus or minus 18. Jeez. Okay, 4. Does 4 go in there? No. 5? No. 6? Okay. Positive, negative 6. Positive, negative 9. 7? 8? 9? Yes, but okay, we've reached the end, right? You see how it comes together in the middle? All right, that's all the factors of 54. Now all the factors of what? 1, which is just plus or minus 1. And this is the nice case, like I just said. If this is plus or minus 1, then your final list is actually just this list, okay? It's just this list. All right, so I'm going to do that. Ready? Synthetic. Here we go. For synthetic, I put the coefficients, which are 1, 12, 45, and 54, right? 54. All right, what number should we start with? I recommend to you that you start with the smallest number and work your way, okay? Let's try 1. Okay, 1. Put a 0 here. Add down. 1. 1 times 1. 1. Add down. 13. 1 times 13. 13. Add down. 58. This isn't going to work. 1 and 58. This is not working, right? That didn't work. Did I go too fast? I went too fast? Yes?
It can't be positive at all.
Yeah, so if all of these are positive, then no positives are going to work here. But either way, that once you get quick with it, you can just like brainlessly go through it. You know what I mean? Just look for 0, look for 0. Did I go too fast? Kind of? Let me see. Let me do it again. I'm going to do 1, 12, 45, 54, and now I'm going to try -1. Okay, 1 comes down, right? 1 plus 0. Multiply -1 times 1, -1. Add down what? 11. -1 times 11, -11. Add down, which is 45, take away 11 is 34, right? And then -34, and that's not 0.
Try 6.
Try 6. Well, I'm going to go in the order. I'm going to go in order because I think the next one would be what, 2?
2.
But I wouldn't use 2. Well, go ahead and use 2. It's not going to work. -2 is not going to work. 3 is not going to work. -3 will. All right? How do I know? I made up the problem. So I know -3 is going to work. So -3 is going to work. 1, 12. Like if there was some short way, like, oh, it's -3. If there was a short, that's the way I teach you, right? This is the way. This is the way. So -3 is going to work as long as I read it off the calculator, right? Okay, let's see. 0 here. 1 comes down. Okay, -3 times 1 is -3. 12 take away 3, 9, right? -3 times 9 is -27. 45 take away 27 is 18. -54, right? -3 times 18. That gives me a 0. Yes? All right. Yes, this is good. Now, just keep in mind, I tried these and I tried those, right? I didn't show you all of them, but I got to what? -3 and it finally worked. Now, if somebody asks me what happens if you have a long thing, like how do we deal with that, right? So pay close attention to this next line that I'm going to write. What does this thing tell me right here? That's a 0, which means what's the factor? X plus 3. Okay, now these numbers, do you see there's 3 of them here now instead of 2? Right? There's 3 instead of 2. But these are the coefficients of my answer. That means the last number is the 18, positive. This is 9 what? What do you think? 9x. And what do you think's in front of that? 1x squared. Ah, we have this, and now we have a quadratic, right? We have this. And now we have to factor this. How do you factor this? Well, either guess and check, right? Guess and check. Or that little thing that I taught you a while back. Or what? Not to factor. To solve, yes. But could we factor this using this method again? We could, couldn't we? You don't want to? But watch. Just hold on. I want to do something because this is actually a pretty big deal. Look. This, I'm going to put this on the side. This right here, this really means x plus 3, and then this is x squared plus 9x plus 18. Y'all with me? If I needed to factor this now, I could do synthetic division again. What would go in my box? 1, 9, 18. That's this, isn't it? That's this. So what I could do is I could make another synthetic division box like this. I know it looks bad, but look, I just need to figure out what numbers to use. So I have to create a list, right? Off of this. Here's the good news. Just continue using the same list. If there's going to be an answer, it's going to be in this list. Where do I start? Well, what worked? What just worked? -3. So you would think move on to what? 6? If -3 worked, try it again. It might work twice. So I'm gonna pick up where I left off. Let's try -3 here. Okay, here's 0. 1's coming down. -3 times 1. 9 take away 3. 6. Holy shit. It's 0, right? Which means what? What's the factor? X plus 3 and X plus 6, right? But remember, that right there was just this piece, wasn't it? You used plus 3 twice. So my final answer is X plus 3 times X plus 3 times X plus 6. Since that's X plus 3 twice, it's X plus 3 squared X plus 6, right? Do you see you could graph this now? You have the zeros, you have the multiplicities. It bounces at -3 and it crosses at -6. Do y'all see that? I mean, I don't know. This is pretty exciting to me. I still get excited. When I stop getting excited about this, I'll stop teaching. All right, so f of x, if I asked you to graph this, right? If I asked you to graph this right now, do we know the end behavior? Yeah, we can figure that out, right? End behavior. Do we know the x-intercepts? Do we know the multiplicities? Okay, in the last 15 minutes, we came up with a way of graphing that. Does that make sense to you? And now we can do it for a lot of things, right? For a lot of things. So next class, what we're going to do is we are going to get into some heavy polynomials, some pretty nasty ones, where we might have to do synthetic division like 4 times to get all of our x-intercepts, right? Yeah, it is cool. It's a super powerful method. All right, so your homework for tonight is the section 5.1. We are behind on the schedule, but the homework for 5.1, I showed you some of it. Do that. And I think a quiz would be great for next class. Because, I mean, this is perfect stuff for quiz, right? Maybe I show you a graph and ask you to give me the function. Or maybe I just give you the conditions and you give me the function. Pardon? It'll be something like I just said. Yeah, I either give you a graph or I give you the conditions. I like the graph idea. That seems... All right, have a great day, everyone.
Oh yeah, I was absent the day this was assigned, so.
Okay, I haven't graded them, so I will accept them. In the future, if you're going to miss, just take a picture or something, text it to me.
Okay,
You know, just like in fairness to everybody, you turning in late, it's not fair to everyone. So, but if you show me on that day, hey, I had it, that's different.